Can everybody see my screen?
Yes.
Okay. Let me know when I should start.
You can start right now.
Okay. Hi everybody. My name is Osama and I am a Master's of Science in Computer Science student, graduate student. This is my final quarter and this is my capstone presentation. And Sam Chung is my advisor. I worked on a cloud-based mobile application for medicine time tracker and notifier, and I named it Medic. So for agenda today, I have my problem statement, motivation, background, related work, approach, design, data collection, data analysis, findings, conclusion, future work, key references, and then question and answers. So for the problem statement, I would like to explain it this way that I was looking for jobs and there were some jobs related to this medicine field and now they were and then I researched about it and then what I came up with if I design a mobile application that would have those technologies that they were asking for, it would better prepare me for my job hunting and further prospects that I am looking forward to. So these are the two papers that I found that I got interested in. The first one is how for the first one addressed a problem that how can we develop a cloud-based cross-platform mobile application for scheduling medicine intake time and using machine learning. Is it possible to take photos of prescriptions and can the app automatically use it to schedule medicine taking time and set alerts? Next, what motivated me further was two more papers I found that they worked on making a reminder for patients to take medicine and through this they made patients more compliant to take medicines because if a patient misses a medicine that would disrupt their medicine taking schedule and then uh, prolong the time that they would take to get better by taking that prescription. And also the other thing is that patients would use understanding doctors' cursive handwriting using AI was the second thing that attracted me to do this. For the background, medication management faces significant challenges hindering adherence. Traditional method lack flexibility and are prone to errors. Prescription image interpretation remains a key challenge. So the related work that I found were using different types of techniques, and they had their models and performance, and they were able to find out how accurate their models were. And I have also compared the technique usability. So these are six papers, and they use ANN, IP, going from left to right, CRNN, and these were the related works that I found. And some use RFID tags like the 6 one in the techniques use. They use RFID tags to identify those medicines and so on. So for the approach, for my approach, what I came up with how I can integrate all of those things. So in approach, I would also like to mention this that how my approach would differ from others because I initially hoped to integrate all of these three things in one application and I wasn't able to find all of these done before. So in approach, the approach integrates a mechanism that combines deep learning, image processing, handwriting recognition, and medicine time tracking systems to automate medicine package, character recognition, and schedule medicine management. Optical character recognition OCR for image capturing, you image cap for image capturing, React Native push notifications to send out notification to let patients know that it's time to take their medicine, and using uh, PostgreSQL for database. Use case: users can effortlessly capture photographs of their prescriptions, which are then digitized and organized within the app, eliminating the need for physical records. This is one thing that this can be used for. The application empowers users to adhere to their prescribed medication regime, making them more compliant so they wouldn't miss any medicines, enhancing overall health outcomes through effective medicine management. Application has a user-friendly interface, allowing individuals of varying technological proficiency to navigate and utilize the app's features effortlessly. So this is the design that I came up with my final version of the app that I have with the final working version of the app. So Medic follows a structured process for medication medicine. New users, so from start to end, new users can create an account with basic details for personalized access and capture prescriptions for their images and uh, digitization and storage in the app. The homepage displays a clear medicine schedule, and users are provided the option to choose from the email or app notifications for medicine reminders. Users configure their reminder timing and frequency. The app initiates timely medication reminders for seamless user experience and improved adherence. This is the GitHub link to the work that I have done. If somebody wants to go ahead and take a look, they can. And this is the demo I have. This is a short video, almost a minute. Uh, um, okay, I'm gonna start it. This is the login sign up page. Once you're done with that, it's gonna show you all these options. Once you have your sign up and login, you can put in your email and password and then log in. And then it shows you this is yes, and then the camera is there, takes a picture. And then the drug name and to take the drug quantity from till save and then drag and it's and there you go. When you're done, if you've taken the pill, you can just press OK. That was the demo of the mobile application that I have. So for the data collection part, this was the uh, I didn't actually work with real world data. So I came up with prescriptions that I that I made using a designing tool. And then so the thing about this mobile application, it works on a specific format of prescriptions. For example, take a look at this prescription. This is one of the prescriptions that I used when I was experimenting with the app initially, when I got the camera to work. And then so the medicine names and then when to take and the quantity, these have to be in this specific format for this mobile application to work. And it doesn't matter if it's handwritten or if it's digitized like this. The handwritten was in the demo. So prescriptions are either handwritten or digital. For the ease of the project, data is generated through Figma. This is an example of the prescription. For the data analysis part, I would say that because I didn't work for the didn't work with real world data, because it would have been not easy to access patients' data, right? So I came up with my own data. So for a proper data analysis, the app would require enough data to work on with, and then when it has done that, it would be able to collect data through this and would then further be utilized in managing patient dosage, intake frequency, interval specifics, dosage guidelines, user preferences, and adherence to medication. So this could all be done after the application is train on enough data. So this was just like a proof of concept that my application works. And for my findings, this is the same table that we saw above in the approach slide. But what my approach was that I will try to integrate all of the three things. Take pictures of the medicines, make a schedule out of them automatically, and then thirdly send notification and combine them in one app. And I was able to do that for my capstone project. But as you can see that mine, in the model performance accuracy, it says not applicable because I didn't train it enough, uh, because I didn't have enough data. So if for my conclusion, in summary, the medic application presents an all-encompassing answer to medication management by incorporating diverse technologies to deliver tailored user experience, able to scan, take pictures of prescriptions, formulate a schedule, send notifications as a reminder to take medicine. Regarding future developments, the application can continuously evolve through updates aimed at enhancing features, including fine-tuning the reminder system and incorporating advancements in health monitoring technologies. These are the key references. And if you have any questions, please. Thank you.
Okay, Han, thank you for your presentation. So now it's time for the Q&A part. Does anybody have a question for the presenter?
Okay, so I expected a question from student. If not, then I will give a difficult question to Osama. Osama, originally you wanted to have a machine learning implementation, but
Mhm.
but you moved this one to future works. So why that kind of things happen? Also, would you explain that one to other student for their capstone project? Go ahead.
I think this question relates to the data collection part, I think, because uh, you need to start your project and do a background work of your project and collect enough resources for yourself that you have a proper plan laid out. So coming to the question, see, at the very end I had to change that because I didn't have enough data, right? To Because machine learning, I would have to have trained models to do the thing, identify the text from the prescription properly and collect enough data to do that. But so that's why shifting to OCR was a good option, the prescription scanning that I'm using right now.
Also, what did you learn through this capstone? What kind of a recommendation do you want to give it to the student who will take a capstone next time?
um so there's this, for your capstone, try to do everything at least 1 year before, honestly, when you're in your final year, or at least 6 months, because collecting data and writing, and especially the related work part, when you are looking for the related work, it is so much time consuming that it takes so much time that you wouldn't have enough time to do the actual thing that you are supposed to.
Okay, thank you.
You're welcome.
Thank you for your presentation.
You're
Okay.
welcome.
Oh, I have a question if it's all right for me to ask.
Yeah, sure. Please.
Yeah, so hi, my name's Armando. I'm a first year, so this is my first quarter at CityU. So forgive me if like some if the question is a little bit simple, but I would like to know, so um like if you extend the project such that um you train your models with like data and like previously like different kinds of handwritings from different doctors.
Right.
I was wondering like how you anticipate like your models and your project, your just overall project, to how do you anticipate that will look different from what it is now?
You saw the prescription, the handwritten prescription, right? It was basic English. Anybody can understand it, right? So in one of the papers that I saw, and it's also, I don't exactly remember which paper it is, but the alphabets, the whole word that the doctors use were first alphabet and then the last alphabet, and then he- if guy who knows the doctor's handwriting knew, if he was reading, if that person was reading it for the fourth time or the third time, they would identify what's the medicine name because of the first and the final alphabet, right? Similarly, like that, if these if any algorithm that could identify these prescriptions, it could be trained on a specific doctor's handwriting and then put in two or three more doctors, and if the first and the last alphabet matches, it could give you an estimate that this is the medicine name. And how long would it take depends on how fast you are able to collect the data, because the data collection part for this type of work, I think there would be policies in that there to maintain patient data, and you wouldn't be able to take out m- get doctor's prescriptions that easily without consent from hospitals, and there would be a policy and security issue in that. Yeah.
Thank you.
Right?
Great. Does anybody have any question for Khan? Okay, I think that's a wrap up for your part. And now we'll move on to the next presenter.
Julia is here. Yeah.